Hello and welcome to the channel. This time, I'm diving into a graphical subtitle editor tool I built. Honestly, I didn't want to overcomplicate my little personal tool. But humans are a spoiled bunch. Aren't we? You want convenience, and suddenly things spiral into complexity. This video is all about the very first version. Since finishing the core features for this project and getting this explanatory video ready, I've already revised it 2 or 3 times and tested a couple of other projects. I have to say, AI has clearly learned a lot from online projects because it helped design an interface that mostly looks pretty decent. But my introduction here will start small and gradually expand. Sure, you can ask the AI, "Hey, make me a perfect flight tracking website," and it will whip up a fantastic structure immediately. The real question is, do you, the person giving the command, actually understand what someone else just built for you? My videos cover both tech and philosophy. I think a lot of the anti-tech sentiment comes from a lack of understanding. And that's not just true for outsiders. Even people working in the tech industry, some of them, even before the big AI boom, would just find solutions online, copy, paste, and run with them without ever really looking under the hood. When you're busy, you might totally do that. However, software engineering shouldn't be treated like a one-off product, especially when you scale it up in a big company with more users. The development team needs to maintain it. If a tool makes it easy to pump out features but you can't make small tweaks later, forcing massive changes, the end users are going to feel the pain. My core belief as a developer is, the more you understand, the less you have to change. I recently heard a working software developer at a major corporation talk about AI's impact on his job, and how it completely changed his workflows. He used to spend a lot of time researching new projects, but AI analysis now helps him get up to speed much faster than when he had to manually dig through the code. Still, he thinks the AI token cost is currently too high, and hiring an engineer might still be cheaper than going full AI. Regarding the high token cost he mentioned, my experience points to 2 possible solutions. 1. Extending AI memory. This isn't always great because the more it remembers, the more data it needs to analyze. Every time I ask the AI for a modification, it seems to reanalyze the entire structure. 2. Being specific. If I clearly specify where things are, the analysis time is noticeably shorter. This is the solution I go with. It's crucial for the engineer to guide what the AI writes. It's not just about a programmer's pride, it genuinely saves money. Back to the Subtitle editor project. For the first design round, the program opens a long, rectangular window. I wanted to at least see the audio waveform moving with the time. When I made a subtitle player before, a simple jumping subtitle was fine. But for playing the audio waveform, since I need to set the precise time, the audio position for the current playback time needs to be a sliding marker. For now, I decided to show 90 seconds of audio on the full screen. I also need an area to display the current playback time. Since I might be editing the audio using other apps, being able to precisely locate the time of an audio issue saves a ton of time. I need it to read audio and subtitle files. The subtitles will change with the time. I also need to adjust the subtitles forward and backward to check the audio segment I need to modify. So, I need a load file button, a play button, a section to display subtitles, a section to show the current subtitle number, and up-down buttons. Now, about my development logs. Sadly, the very first version of this project was completely undocumented. Here's an editing screenshot to give you an idea of the finished look at that time. The finished features in this screen were reading audio and subtitles, displaying the audio waveform, showing the time. Once the play button is pressed, the waveform moves slowly upwards. The subtitle area shows the currently playing subtitle and its number. If you hit the up-down buttons to control the subtitles, the waveform repositions. However, the waveform kept running, which made it hard to define the exact position for audio changes. Second design round. In the second design, I added the start and end positions of the currently playing subtitles audio to the waveform area. I added a set of up-down buttons for adjusting the subtitles start time and another set for the end time. The full screen display time was changed from 90 seconds to 30 seconds. I also added a pause button and a save button. The final interface looks like this. The finished features included ability to pause the audio, ability to adjust subtitle times, ability to save the file. Basically, all the features I wanted were there. But adjusting the start and end times using buttons was really slow. It would be much easier if I could just drag the start and end times directly on the screen. Also, the subtitle playback position could only be moved forward or backward using buttons, which became a pain when editing sentences further down the timeline. I initially didn't want to add subtitle editing to this little tool, but I realized there are times when I really want to change the subtitle content itself. Checking the AI's work. The first usable version is complete at this point. Next, the video will show my workflow, starting from a text file and finishing with the fully edited subtitles, interspersed with explanatory screenshots. Now, let's actually check out the project the AI completed. The project structure on anti-gravity looks like this. First, the requirement.txt file. It only lists Pygame, but that's not all. This project needs to open a window, so it needs the tkinter package. Next, let's look at the entry point, main.py. The main.py file mainly defines a class called Voice Subtitle Editor. Its main function is to display and update the window. If we look at setup_UI, we can see the time display block, the up-down buttons for the subtitle file start time, the other set of buttons for adjusting the subtitle file end time. It then calls the waveform widget class to draw the waveform area. Following that, the save button, play button, and other interactive components are defined. If you want to change any functionality on the screen, you can find their actual names here. The functions executed by those components are defined below. Next, let's look at audio_handler.py. Audio playback and position adjustment are mainly controlled by this class. The Pygame package is mostly used here. The AI divided the project's functionality into 4 main parts. 1. UI, user interface. 2. Audio control tools. 3. Subtitle control tools. 4. Waveform area control tools. Frankly, the planning is quite clean. Since we only defined playback for the audio, this tool is much simpler compared to the others. Moving on to subtitle_manager.py. This file needs to handle the correct structure of the subtitle file, so it defines a separate subtitle class. The subtitle manager deals with a list of subtitle components. Dismantling and rebuilding the structure is a very important part here. Other simpler parts include helping the interface find the start and end times of the subtitles. Finally, let's look at waveform_widget.py. It's responsible for updating the waveform drawing. Something to note here is that it uses subprocess. This means the waveform area opens a separate child thread to update itself. It basically runs at the system's screen refresh rate. I was quite surprised that the screen here is maintained by tkinter, not by Pygame, which is specialized for Linux game screens. This tool needs to analyze the audio, Draw and move the audio waveform, and set the current playback position, as well as the start and end times of the subtitle file. That concludes the introduction to the first usable version. See you in the next video.